For today's lesson, we are going to talk about organizing multivariate qualitative data, specifically through the use of contingency tables. Imagine that you conducted a survey and collected information about different characteristics of your respondents. For example, you know the blood type and sex of each respondent. If we look at the raw data, we might see a long list of individual responses. While we can still get information from it may not be easy to immediately see how these two variables are distributed together. So, how can we organize this information in a way that makes the relationship between the variables easy to see and understand? This is where contingency tables come in. A contingency table, also known as a cross tabulation or crosstab, is a statistical table that displays the frequency distribution of two or more categorical variables, showing the counts or percentages for each combination of categories. It allows us to organize categorical data according to two or more variables at the same time. Instead of looking at each variable separately, we can see how the categories of one variable are distributed across the categories of another variable. For example, we can use a contingency table to organize our respondents according to their blood type and sex. There are two important things to remember about the purpose of a contingency table. First, it provides the basic picture of the interrelationship between two or more variables. It gives us an organized view of how the categories of different variables are distributed together. Second, it helps find the interaction between two or more variables. By comparing the frequencies across different categories, we can observe patterns, similarities, or differences between the variables. So, contingency tables are useful because they allow us to turn a large amount of categorical data into a format that is much easier to read and interpret. Let's now proceed to our first example. The problem says, construct a contingency table to summarize the relationship between blood type and sex. Before we begin our demonstration, please make sure that you have the required dataset. You can download it using the link provided in the description box of this video. Once you have downloaded the file, you can follow along with the demonstration. For this example, we want to examine the relationship between two qualitative variables, blood type and sex. Now let's create our contingency table. I'll go to Analysis, then select Frequencies, and then Independent Samples under Contingency Tables. Now we need to assign our variables. Take note that when creating a contingency table, the variables can be interchanged between the rows and columns. For example, we can put blood type in the rows and sex in the columns. Or we can put sex in the rows and blood type in the columns. Both arrangements are possible. What is important is that we understand how the table is organized and how to correctly interpret the frequencies. For this particular example, we will move blood type in the rows and sex in columns. Once the variables are properly assigned, the software will automatically generate our contingency table. And here is our output. As you can see, the different blood types are listed in the rows while male and female are shown as columns. This allows us to see how the respondents are distributed according to both blood type and sex. For example, we can see how many male respondents have blood type A, how many female respondents have blood type A, and so on. Once we have our output, we can copy the generated table and paste it directly into our document or file. And don't forget to properly label the table. We should add a table number and a descriptive title right above or below the table. For this example, we can use Table 1, Contingency Table of Blood Types and Sexes. This makes our table easier to identify and reference when we discuss our results. Before we interpret our table, let's first identify its important parts. First, we have the categories. These are the different groups or classifications of our qualitative variables. In our example, the categories include the different blood types and sex categories. Next, we have the frequency. Frequency refers to the number of respondents belonging to a particular combination of categories. For example, if we look at blood type O and male, the frequency is 7, meaning there are 7 male respondents with blood type O. Next, we have the marginal totals. These are the totals found at the edges of the table, specifically the row totals and column totals. They tell us the total number of respondents for each blood type or each sex category. Finally, we have the grand total. This is the overall number of respondents included in the dataset. In our example, the grand total is 30 respondents. Now that we know the parts of the table, let's answer some questions based on our contingency table. What is the distribution of the respondents according to sex? The key phrase here is according to sex. So we need to look at the sex column totals or the column marginal totals. Therefore, the distribution of the respondents according to sex is 18 males and 12 females for a total of 30 respondents. What is the distribution of the respondents according to blood type? This time, the question asks for the distribution according to blood type. Since blood type is in our rows, we will look at the row marginal totals. Therefore, the distribution of the respondents according to blood type is 4 with blood type AB, 7 with blood type A, 12 with blood type O, and 7 with blood type B. Notice that among the 4 blood types, blood type O has the highest frequency with 12 respondents. Now, let's move on to questions that require us to focus on a particular row or column. What is the distribution of male respondents according to blood type? Let's look carefully at the wording. The question asks about male respondents, so we will focus on the male column. Then, we look at the frequencies for each blood type. Therefore, the distribution of male respondents according to blood type is 2 with blood type AB, 4 with blood type A, 7 with blood type O, and 5 with blood type B. If we add these frequencies together, we get 18, which matches the total number of male respondents. What is the distribution of respondents with blood type O according to sex? This time, the key phrase is blood type O, so we will focus on the O row. Then we look across the sex columns. Therefore, among the respondents with blood type O, 7 are male and 5 are female for a total of 12 respondents. Notice that the total also matches the marginal total for blood type O. Now let's move on to our second example. The problem says, construct a contingency table to summarize the relationship between sports preference and sex. For this example, our two qualitative variables are sports preference and sex. Again, remember that the variables can be interchanged between rows and columns. But for consistency with our previous example, we will place sports preference in rows and sex in columns. So our table will have the different sports preferences in the rows while male and female will be our columns. What is the distribution of the respondents according to sex? Since the question asks for the distribution according to sex, we will look at the column marginal totals. Therefore, the distribution of the respondents according to sex is 18 males and 12 females for a total of 30 respondents. What is the distribution of respondents according to sports preference? This time, we look at the row marginal totals because sports preference is in the rows. Therefore, the distribution according to sports preference is 12 who prefer football, 10 who prefer soccer, 3 who prefer auto racing, and 5 who prefer baseball. We can also observe that football is the most preferred sport in this dataset, with 12 respondents. What is the distribution of female respondents according to sports preference? The key phrase here is female respondents, so we focus on the female column. Therefore, the distribution of female respondents according to sports preference is 4 who prefer football, 5 who prefer soccer, 2 who prefer auto racing, and 1 who prefers baseball. If we add these values, we get 12, which matches the total number of female respondents. What is the distribution of respondents who prefer baseball according to sex? Now, the key phrase is respondents who prefer baseball, so we focus on the baseball row. Therefore, among the respondents who prefer baseball, 4 are male and 1 is female, for a total of 5 respondents. Congratulations on finishing our lesson for today. But of course, learning does not stop here. You are now ready to practice what you have learned in this lesson. And that is our lesson on contingency tables. Today, we learned what a contingency table is, why is it useful, how to construct one, and how to interpret the information presented in the table. More importantly, we learned how a contingency table can help us organize two or more qualitative variables and make it easier to see how their categories are distributed together. Remember, don't just look at the numbers. Look at what the rows, columns, and totals are telling you.